in hydro, and hydro means water. Then there's another is small. What is that? Then there's a question that what is large hydropower, what is big hydropower, what is small hydropower. So what is the difference that we will discuss that. We will also try to clarify, I'll try to clarify that what is the meaning of this hydropower and large hydro, mini hydro, small hydro. You might have studied, you might have come across with these terms, various terms related to hydropower. Okay, of course, the development. We need to develop these resources. So we must know the technology, we must know the various points concerned for development of these resources. Then there's another topic is connected with the environmental impacts. So that's also we will discuss, we'll try to do that. Of course, I tell you that if you talk about the hydropower development, then this term, this environmental impacts becomes very important, very that you can say this is a serious thing you have to deal with along with the hydropower development. But when you talk about the small hydropower development, so that means this environmental impacts, I can say that it is not so important with the small hydropower, but still we have to discuss something which is very much relevant to development of small hydropower. Is it okay, sir? I am audible?
Yes, sir, you're audible.
Yeah, please give me your feedback in between also. Otherwise, it's very difficult to speak, at least for me, to in front of the computer if I don't get the response from the participant. But at least, please, madam, you help me in that.
Yes, sir. Yes.
Okay. So we'll start with that. I think, again, I have to connect this lecture to make this interesting. That among all renewable energy sources, it's not necessary to define what is non-renewable and what is renewable. I think that you know all these things. But among all this renewable energy, there is a source which is known as the hydro. That means that some energy available or some power in hydro, which we want to tap that in order to fulfill our requirement, along with the solar energy, wind, biomass, tidal, geothermal. So hydro is also, nowadays, I think earlier, if you talk about the few years back, even in India, I'm talking about, because you know that there is a dedicated ministry which is dealing with renewable energy sources in India, that is MNRE, Ministry of New and Renewable Energy. So in that, the definition with them, 3 years back, only small hydro was considered as the renewable. And the large hydro, there's no space of large hydro in renewable energy. But now recently they have included, that means hydro, all hydro is renewable. So that is the information I'm giving. So now it's not, I think it's not in a domain, but I think now you will receive some information or documents or some guidelines that hydro is hydro. Earlier it was large. Pardon? Hello. Somebody want to ask? Hello, madam.
Yes, sir. Yes, sir.
Somebody wants to ask something? No.
No, sir. No.
Okay. Hello. Should I proceed?
Yes, sir. Yes, sir.
Okay. So then,
yes, sir.
Yeah. So I will not be talking that very, very advanced thing, because first, I think as far as the academic concern or academicians concerned, or as a teacher, that means if we want to communicate, we want to teach something to the students, so we should start with the basics. Don't leave the basics. I think, of course, my interest will be the emerging technology or the developed technology, but it will be better if you spend few minutes or few hours, depending upon the time available to you, that with some basics. Start with the basics. So that means I'll be discussing some basics, and depending upon your understanding, you can ask me the advanced thing also. Why? Because I feel that if I start with the advanced thing without discussing the basics, then I'm sure that you will not be very happy with that. So it depends upon that how advanced you want to talk in this. But my lecture will start with the basic things. So in this case, let me tell you that why we are doing this, why I'm teaching to you, why I'm discussing the things with you, why you are in the class. Our objective is that if I find or you find some potential, some site where hydropower is there and which cannot be used, which cannot be used directly to fulfill our requirement. So we can tap this, we can convert this into useful form of energy, and then we can fulfill our requirement. So I think the sentence I'm talking about, this is applicable all renewable energy sources. This is this applicable for all renewables. Why I'm talking about this renewable energy source you cannot create. It is readily available to me. But the problem is that in what form it is available to me, I cannot use this directly to fulfill my requirement. So then what happens? That means then engineers, scientists' job come in. Because I want to convert that available form of energy into useful form of energy. So that means my task or your task is that you convert that useful form of energy, which is available in its original form, in the useful. That is, suppose I need electricity. So if I need electricity from solar energy, so I think you should know that how, because solar energy cannot light a bulb. So that means that available form, which is coming in the form of the radiation, I want to convert into electricity. That how? That I have to introduce the system. The system is solar photovoltaic. So that photovoltaic is designed by engineer. So that is the things. So here also, and this is the beauty with the solar energy. That means if you want to heat energy, your requirement is heating. So that means solar energy, there is a provision. There's a beauty with solar energy that you can convert electricity directly or you can get the heat directly. But in hydro, if you want to get the useful form energy, it is available in the mechanical. That means first you have to convert the available form in hydro into mechanical. That is the only route. And after that, mechanical energy can be used to derive the generator's electricity. So this is the things we have. If you want to get the heat energy from hydro, so there is no direct route. You have to convert into mechanical first, then mechanical will be used to derive the generator generate the electricity, and then again electricity will be converted to thermal. So I think we'll understand this first. Sorry. So it is there. That means it's I always just advise or discuss that whenever you want to deal with these renewable energy system, any kind, it could be wind, it could be solar, it can be small hydro or biomass. First, we have to assess the potential. First, you should know that how much is available. This is one thing. And the second thing is, in what form you need energy. Of course, we are always interested to convert the best form of energy. That best form of energy is always considered as electricity. Then you think to design the system, because the engineer task is to design the system. Which system? Which will convert the available form into useful form. Now the designing the system, Which design? It should be the optimum design. Optimum design means the system should be reliable, cost-effective, and efficient. All are related. That means if you think that the system should be very highly efficient and it is not reliable, then what is the use of that? And if it is a reliable and efficient, highly efficient and highly reliable, and it cannot be affordable, then again, it is not of use. So that means these three terms you have to consider always for any kind of system in renewable energy, like in this also small hydropower. So that means, let us start with that. That first thing is, you should estimate how much is available to you. And for that, you should have you have to identify the site. And how you will know that how much with you? You have to estimate. And how you will estimate? That means you should know that what is the basic form of energy, so that the applicable equations can be used to estimate the potential of a particular renewable energy. So in particular, small hydropower. So I think I'm talking about, let us understand that what is the route to get the electricity from the hydro. So I think this is the simple schematic, or you can understand. So basically, what is the available form? It is the potential energy. What is the form of energy available in hydro? Potential energy. This immediately in physics we can say mgh. So that is the form. So here m is the mass, and g is, you know, that there's a gravitational force, and the h is the height, vertical height. And here this vertical height is known as the head. In hydro terms, it is known as the head. In the beginning, please give me the response whether I should continue like this or I should skip all those things.
Please continue, sir.
Please, madam, I think you are speaking on behalf of the participants, no?
Yes, sir, yes.
So how will you get the response from them? Because my concern is the participants.
Okay, so I request some of the participants
yes,
to respond
please,
to you.
that's why, because otherwise I can turn my direction accordingly. There's no problem in that. So,
participants from hall, please respond.
It's very difficult nowadays, actually.
Yes, sir. Yes, sir. Please speak loudly.
Yes, please proceed, sir. It's very interesting.
Okay, should I go like this only?
Yes. Of course.
Okay. So this is the thing that we have to understand. So in order to estimate the potential of any renewable energy, I'm talking of hydro. So you have to use some power equation. Power equation means because the energy or the potential, it should be in some quantity, and quantity will have some you can say the dimensions. So in that case, this mgh is the potential. What is h? H is the vertical height. It's not this I think length of any water conducting system. So here only I'm talking about, suppose this is the upper stream and this is the downstream of water. So I can say head is up to this point. This vertical height is head. It is not the length of this. It is not this. So I think because it's a potential energy. So in that case, now let us discuss what is that power equation with which we can estimate the potential energy. So I think this is again a very, very the schematic of any typical or a very simplest hydropower station. So in that case, I think you can let me see whether it's working. No, anyway. Okay, so I'm just using this cursor only. So this is the thing, that means this water level is the head. So we want to measure this, how much head. That means at what height, from which height water is coming to me, where I want to convert this into useful form of energy. And what is the quantity? This is a discharge. I call this a discharge. The flow rate. That what is the quantity of, or the what is the mass? Mass. I think again it's our convenient, because mass cannot be measured directly in order to estimate the potential energy. But this mass can be measured in the flow rate. That means the flow rate is the how much quantity, how much volume of water is flowing per unit time, in unit time. So that means volume can be in liter, it can be cubic feet, it can be in cubic meter. So ultimately, we measure this flow rate in cubic meter per second. So these two things you have to measure. And then finally, this mgh. So that means that power equation is derived. It's a derived term. It's not, of course, it is derived from mgh, but after conversion and everything. So that means we finally, this is the power equation. This actually, it's a rho g is no 9.81 is g. 9.81 into flow rate is cubic meter per second. I think it's written over here. And head is in meter. And the overall efficiency of the system. That means efficiency means I want to transport this potential energy. This water is transported through some system. And then again, there is another machine which will convert the potential energy into kinetic energy. That kinetic energy is used to derive the generator, and then finally electricity. So that means that I'm talking about overall efficiency, overall the system efficiency. So that we have to consider. So that much power we can get in kilowatt. So if you want to write, or you can remember, that means if somebody asks you that how you will estimate the hydro potential. So you can say that ideally it is 9.81 into Q into H. H is the head. And how much you will get, that depends on the efficiency of the system. So that you will get. It will be in kilowatt. So flow will be in cubic meter per second. Head will be in meter. Then the unit of this kilowatt will be in kilo. That will be in kilowatt. Power will be in kilowatt. If you take the flow rate in liter per second, it will be in watt, because 1,000 liter equal to the 1 cubic meter. So this is the things. I think now this it's a because in 2 hours I will try to discuss all the basics and some concepts, so that some interest can be created in you to take up this very important renewable energy sources for your under your research, or for anything, for development. But it is not possible to cover all the details, how we'll measure the head, how we'll measure the discharge, but I just discuss the basics. So the head, if you have a existing reservoir, so in that case, directly you can just take the level of the upstream and downstream. And the difference of this will be the head only. It's a gross head. And if you don't have, like, suppose you have a, you can say it's a plain side, virgin side, that means there's nothing, like there's a source, there's a stream is flowing. Then in that case, let us talk about this. Suppose in hilly area, there is a stream and you want to know that how much head will be available. So that means the source is only topo sheets. The maps are there. So nowadays the maps are available. Of course, some restricted area will be there, but you can get those maps. So in that map, the contours are this. You can see there. Suppose this blue line is a source, is a river or a stream. So in that case, the stream, suppose I can say that this will be the appropriate site to divert the water, and this diversion of water. Hello? this diversion of water, you can take the level from here, or you can check the what is the elevation on this line is given. And then if you want to put the powerhouse over here, you can see the reading of this contours. So that difference of that will be the static head. You can say that's a level between two. Otherwise, there's another methods, that means where you can take the altimeter at that level upstream and downstream, and difference of that will be the. So I can say that the measurement of head or any, because the civil engineers, they are using the theodolites to know the difference of the levels. So I think it is the simple method. It's not the tedious method to know the head for a given site. So that means by applying any convenient method, which is basic methods are available, or some advanced methods also there. So you can apply those and you can measure the head. So measurement of head is not the problem. The problem is the discharge. Why the discharge is the problem? So I can say because once you have decided that I take the discharge from this side and I want to go, I'm going to install the plant, this plant at this level. So that means this head will remain almost same. It is not going to change, because you cannot, of course, slightly in reservoir, some level may be different depending upon the level. But in the small hydro, these reservoirs are not big reservoirs. It's a very simple, very, very shallow, very small reservoir. So that means hardly any difference in the reservoir. If it's there, it's okay. That can take up by the turbine. But the level or the head almost remains constant, or slightly difference will be, or the variation will be within the limit. But the discharge is that, because most of the sites are runoff river and they are from the natural stream. So because we don't have the this conventional method, we don't have the storage. So whatever discharge available in the stream, we will consider that. So you know that sometimes a stream during flood is full of water. There's 1,000 cubic water will be there, but few months it can be dry. It will be zero. So that means discharge vary from 0 to the maximum discharge. So now I have to fix the capacity of the plant in kilowatt. So which reading I should take? Not 0, not the highest. You can say that the average. Average is not a good average, 0 to and the 1,000 cubic. It is not good average. So that means that good average, or the average to take the design discharge under this much variability, we just adopt some mechanism. And that mechanism in, I think, the civil engineers or some other branches where they know this flow duration curve. That means we try to understand that in what way the discharge vary throughout the year in that stream. And then we find out that over maximum period of time, what discharge is available to me, so that, and what capacity will be beneficial to me. So that discharge is to be determined. That is known as the flow duration curve. And it's a simple mechanism I'm talking about. Of course, I'm sharing all the slides which I have. It looks like a complicated slides, but try to understand that is how we generate these, how we tackle this flow duration curve and how we draw the flow duration curve, because this is the key point in order to estimate the why I'm just spending so much time on that. That means this point, that this estimation of the potential is this, if you are accurate, so that means the success of the plant will depend upon the how you estimate the potential. If you commit the mistake in that, so I don't think that your plant will be sustainable or it will be cost effective. So that's why many years these hydro developers, they spend on this exercise. It depends upon the, again, It depends upon the size of the plant. If you are talking about the few kilowatts, say 5 kilowatt, 10 kilowatts. So I will not say that you do this exercise. No, it's not there. You just go to 2-3 days or just observe, or you can ask the local people that what is the trend of the variation in discharge, variation of discharge in this stream, and depending upon that, you can fix the plant capacity. But if it's in megawatt, and again, it's how much megawatt? If it's about 2 megawatt, 3 megawatt, 5 megawatt. So I'll tell you that at least 2 years discharge must be there. Two years discharge data should be there. And if it is a large hydro, say in megawatt figure, this 50 megawatts, 100 megawatt, 1000 megawatt. So that means it cannot be, the capacity cannot be determined based on the 2 years, 3 years, 5 years, at least 5 to 10 years discharge data should be there. So accordingly, you have to consider, and I think it's clear to you that this, if you are dealing with a very small capacity, say 5, 10 local, you want to install a locally this hydropower for decentralized mode, so don't do this exercise. You just ask the local people that what is the variation in that, and then based on that you can fix. But if you want to develop the conventional or the larger capacity, then you have to you have to be very okay. So what is this? Try to understand it very easily. We have time. There's no problem in that. So don't worry about this. So let me tell you that just look at this slide. I want to set up a plant so that I want to determine the capacity. What should be the capacity of that plant? So what exercise I have to do? That means at least I should have the daily discharge data during for 1 year, at least 1 year or 2 years. That's what I'm talking about. Let us talk about that 1 year data I should have. And I tell you that there are some dedicated agencies that can be nodal agencies, that can be private agencies. They are doing this exercise for a potential stream, or where they find that there's a potential of hydro. So they are dedicatedly doing this exercise. That means collecting the data. So you can get from those. Or if they don't have, then you have to put some exercise. You have to do some exercise for that also. So what is the daily discharge? So that daily discharge means we assume that discharge may vary seasonally. Discharge may vary monthly. But hardly any variation or too much variation will not be there over a day. That we assume. So in that case, in the stream, you have to put some flow measurement equipment, flow measurement instrument, and then every day you have to measure that what is the discharge in that stream. So here that I'm talking about this, suppose a particular site, these are the actual data actually, that's why I've taken from here. So that means in the month of January, if I start measuring the discharge in that stream in the month of January, so I'll start with that. So it is like that from January 1, 2, 3, 7, discharge, this is dry. There's no flow in that stream. And up to that it start again. So for throughout the month of January, I have measured daily discharge. Now, again, you will ask that how you will measure the discharge. There are so many techniques, even simplest techniques are there. These are available there. So let me tell you that if you are familiar with the weir, when this V notch, rectangular notch, weirs you might have studied. So that is a very, very, very fantastic instrument, simple instrument. You install the across the stream, and then find every day you measure the this head in that stream. Means the level in the weir. I think if you are familiar with the weirs, V notch, you might have heard the rectangular notch or trapezoidal notch. So any weir you can install, and then it's very simple to get the discharge in the month of February. So that means for all the months you can get the things. Now there should not be any question. You should not that say, will I wait for 1 year or 2 years? No, no, no. These data may be available, will be available with some agency. So you can get from them. Or somebody asks you to develop a hydropower for his site, or he might have identified the site, or some nodal agency for a state. They have many sites. Or I tell you, that means like our department, we have data bank for many states like Himachal, Arunachal, Uttarakhand, Chhattisgarh. So we have all this data. That means what is the discharge and the head in the states which is available, which exists in this state. So that you can get from there, from them. So, but you have to deal like this. So then this is throughout the year. That means all the 365 days, you have the data. We call this a daily discharge data. So what we have to do next, this is next year also. This is the next year. This is next year, but I'm just taking the example for 1 year only. So that means now, how many years data you have? 2004, 2006, 2007, 2008. That's 5 years data you have with you. So these you have arranged. Now, what you have to do, take the 10 days discharge. Now, I can say that throughout the year, not too much discharge variation will be there. But then you take the 10 days. Suppose in the month of January, from January 1st to January 10th, you have one value. That is one average. So in the month of January, how many value you will have? How many value you will have? So you can say that how many value you will have in the month of January? 3, because 10 days are average. In the month of February, 10. In the month of March, like this. So instead of 365 value, you will have 36 value. I think that one day here and there. But this daily discharge 365 in a year, and that 10 days average is 36 only. So you have to deal the 36 values only. So now what you have to do? Then okay, this is the in 1 year, that means 3, 3, 3, and the 3 here. So total 36 values. And for each year, 2004, just do this exercise. It's a simple exercise in the table. Then finally, next what you have to do, you put those values, that the 36 value, in descending order. Because let me tell you here, up to this, you have January 3, February 3, and these are the value. Now, in the next step, I'm asking you that put all these values in descending order. Then there won't be any demarcation that is the August value or September value or January value. So these now, this is all the values are descending order. So here that there's no January, February, or the first or second. That's a descending order for all the years. You got it? I think you do understand that, because you cannot give the response directly, but I feel that you are following this. So now what you have to do, when you put the descending order, so take this average for each R. That's the highest value average. That will be the first value in this last column. And that will, I consider this is the things, I think, here. And I think I had this data in Cusec. You know, that's the cubic feet per second. But ultimately, when I use the power equation, that will be in meter cube per second. So I have to convert this Cusec into Qmax. So around 35 point something, it will be 1 Cusec, 35 Cusec will be 1 Qmax. So that means this value will be converted into Qmax. What is this value? This is the highest value in that year, average for all the years. So then let me tell you, then all these values which you have collected from January to December for all the years, now you will have only one value for that. That total value will be 36 only. I think this is the last value, and in Qmax. I think you got it, what I'm talking about. And if somebody want to discuss after that, you can discuss then when you will be allowed to connect. So this is the first, this is the last column, and the first column that here you can say, that means this is the time equaled or exceeded that discharge. That means a percentage time. I'm interested to know that out of the 36 days or out of 8760 hours in a year, how many hours or how many days the discharge will be equal to that value or exceeding with that value. So in that case, the first column, it is generated. I not measure this. It is like this. That means take this 1/36 into hundreds. That will be the percentage duration. This will be 2/36. This will be 3/30. Last value will be 36/36. That is the 100% time this discharge will be available to me. That is my concern. My concern is that I want to know that for a particular discharge, how many percentage of time in a year it will be available. So if somebody asks you that, please, what value will be available throughout the year for that particular area I'm talking about. Of course, this particular example have many zeros, so that don't worry about that. But I can say the minimum discharge value will represent the maximum duration. That means if I say that zero discharge will be available for how many days, you can say all the 365 days. So, and the maximum discharge, this maximum discharge will be available for the minimum time duration. So that is the things, these two columns I want to draw. This x-axis, this is the first column, and the y-axis will be the last column, and that will be the this curve. मेरा lecture है 1 बजे के बाद. So I think this is the things here. This is the discharge, and this is the percentage of time. So this curve, the shape will be this. So if somebody want to, let me tell you that I think again this exercise is a very extensive exercise, but I'm just giving that some basis of that. So I tell you that this is percentage time. I think this axis is missing over here. Sorry. So this is the percentage of time. That means here this 100%. 100% time means 365 days, and this is 0. And here this is the value. This value. This is the value. So I think now, based on the experience I'm talking about, if you ask me that what percentage of time I should fix the plant capacity to determine the discharge, so I can say nowadays even up to 40%, minimum 40% duration we can fix the plant capacity. So what is that? Suppose this is 20, this is 40, this is 50, like this. So if I say this, I think this is 40% here, just assuming that. So I think this 40% you can say, so what is the value here? That will be the discharge. So that means the design discharge for that capacity is based on experience. Otherwise, what we have to do, we have to take each and every value. Let me tell you that you can fix the plant capacity for this discharge also, the maximum discharge. So your plant capacity will be, because head is constant. Head will be whatever you measure at that side, that will be the head. And the discharge, if you consider maximum discharge, you consider that bit. So you will have the maximum potential, maximum power. But how many days you will that potential will be available to? Very less duration. Say for 5 days, 10 days. That's all out of 365 days. And rest of the time it will not produce the full capacity. But what you have done, that means initially you have invested a lot of money to have the big size of machine, but that machine will be, for few days, it will generate a maximum power, huge power, but for very low duration, very less duration. So in that case, that most of the time the machine will be ideal. So that means it will not be, plant may not be cost effective. And what you have to do, you just take this for this duration, plant will be in operation, and the capacity will be less, but of course the duration will be there. Then you can find that what is the economy. So it will be better. I am sure that it will be better. Then go for the less discharge, increase the discharge duration like this. And after that, the duration will be more, but the capacity will be small. So after that, you will find, no, again, it is not economical. So that means this optimization you have to do. So I'm telling you that based on the experience, so if you go up to 40% duration time, even the plant may be economically viable. So that is the things, this is the potential estimation I'm talking about. So just for 2 minutes, if madam, you can connect somebody that any doubt in order to estimate the potential, I'm here to explain that. It's better that, otherwise, after sometimes you'll feel bored. Well, there's so many things I could not explain the thing, but yeah, please ask.
Is any participant having any doubt? Please, you can ask to sir.
Regarding potential estimation. Madam, you have marks for that?
Yes, sir. We are.
Can you please tell them that if you will not ask the question, 2 marks will be detected.
Yes, sir. Yes.
Actually, we Indians, अरे भाई, हम यहाँ पे बिल्कुल don't think I'm a teacher, I'm an expert. I'm just discussing and have interaction with me, ask the question, and if any, my actually tension is that if something new you can carry from this lecture, I will be satisfied. Otherwise, 2 घंटे में बोलता रहूँगा कुछ आप बोर होते रहेंगे.
Yes, sir. We generally sir take the discussion session at the last after you finish your presentation.
Okay. So okay, that you that means how many? Let me tell you that up to what time I should speak.
So you can take your time. We are having the session up to 1 o'clock. So once you finish your presentation, we will start with discussion.
No, it depends upon that. How much time they need to discuss. So accordingly, I will finish that. Otherwise, I'll keep on speaking.
Okay, sir.
Hello, 15.
Yes, sir. We'll have the. Yes, sir. So one participant wants to ask question. I am taking his question.
Yes.
Dr. Rupnar, please ask your question.
Hello, good morning, sir.
Yeah.
Myself, Dr. A.K. Rupnar, sir.
Yeah.
From Maharashtra. Sir, my question is, as you, when you started your presentation, you said that previously the hydropower is not considered as a renewable source in India.
Yes.
But now I think from past 3 to 4 years, they have included it as a RE power.
Yes.
So what was the reason that they are not in India? Hydropower is not considered as a RE.
Yes. I think initially this small hydro in India, they have started with a very small capacity plant. Like actually definition, I'm just going to define after this slide. But anyway, I'll just try to answer this. So then all the small hydro concept was based on the you can say this the flowing stream potential we are there's no concept of construction of a reservoir, and all the large hydro were based on the reservoir base. So I think nowadays no hydropower plant is being constructed based on the reservoir, the large, huge reservoir. So that means the capacity of those plants are limited. I think you got it. Yes. What is the definition of renewable and non-renewable? Renewable means renewable is it is not exhaustible. But the large hydro, when you cannot submerge the lot of land to build a large hydro, So there is a limitations of that. That means up to certain limit you can build the hydropower plant. But nowadays the dam-based plants are not there. Even they have increased the runoff river plant, the small hydro capacity. They are going to increase up to 100 megawatt. Earlier it was 3 megawatt. 5 megawatt, 10, 15, now it's 25 megawatt, and they are increasing 25 megawatt to up to 1000, this 100 megawatt. So that is also a large hydro. But those are not dam based. I'm telling you that reservoir based. I think you got the reservoir based. No?
Yeah.
So there is a difference between that was the concept of that. So now then there is no reservoir based hydropower. Then it is all runoff river, this canal based. You are not creating the reservoir. So it's almost renewable energy.
Okay, thanks.
Please again ask me that, but you should be fully satisfied. That I tell you that one sentence here.
I got it.
That means that a good teacher is that who confuse the student totally. But I think it's I say is the one sentence. But he should leave the class after reviewing that confusion completely. So that is my concern. And what is the best student? That initially he should be totally confused, completely confused. Then he will ask. Otherwise, he will not ask. And he should let the teacher go out of the class before reviewing his confusion. So that's why I'm talking about. You have the confusion. I consider you a good student, good participant. But I want to be myself a good teacher so that your confusion should be totally removed. It's okay?
Okay, sir. I got it.
Right. So that's why I'm asking participants, if you want to be a good participant, you keep on try to be confused and ask the questions. Okay. Hello?
May I ask a question, sir?
Yes, please.
Sir, actually the small hydro plants are means mostly we can install them in hilly region, like in Maharashtra and Konkan region. There in rainy season the water flow will be only for 3 to 4 months. So will it be feasible to install small hydro plant on those streams? Means because the big rivers also, they are available only for 3 to 4 or 5 maximum months.
Yes. That's why it's a good question, because that depends upon this hydrology I'm talking about. That means I think you find that in this table that in lot of this many duration, that means few months or many years, the discharge is 0, 0, 0, 0. So that means you have to consider the discharge, because the head will, there's no problem the head. If it's a large head, it's a high head, medium head or low head, that's there. But the discharge is very important. So that means I think you can find that there are so many 0, 0, 0, 0. That means these months there's no discharge. So based on that, you draw this curve. And then depending upon that, I think that's why you have to understand this. I'm not sure that it is clearly, but it is available in the net also. You have to deal with this flow duration curve and then find out the economics. Then only I can say that it will be feasible. You got it?
Yes.
I think नहीं अभी confusion है, चेहरा में देख रहा हूँ तो अभी confusion है.
No, sir, then what to do if
so that's why I told you in the very beginning, that means this axis is a percentage of time. So I told you that nowadays, if you fix the plant capacity up to 40% time duration, so that will be feasible. So in this case, suppose this is 40%, I think there's no value is given. So that is corresponding to this 40%. If I take this discharge, hello?
Yes, sir.
That this is a design discharge into the head you have estimated, and 9.81 into Q into H. And then whatever capacity you find, that capacity will be economically feasible for this site. It's not clear?
Yes, sir. Clear, sir. While designing, we have to, before that, we have to plot.
Yeah, you have to draw this flow duration curve, and then you can find out. And as a thumb rule, I'm talking about, based on our experience, that people still go for the 40%. Earlier, they recommended in 80s, because the large hydro engineers were there, they didn't allow that. At least it should be 80% dependability. But now the readily available equipments are there in the small hydropower, so cost will go down. So that means even you go for the 40%. I think this way you can think about it.
Okay, thank you, sir. There is another question in the chat box by Dr. Tiwari.
Yeah.
Why big hydro was not used to consider as a renewable, and why reservoir based is not renewable?
Yes, madam, please.
Sir, there is one question from Dr. Tiwari. He is asking why big hydro was not used to consider renewable.
I tell you that the large hydro we considered, or I think you can take this history, all the large hydro, they are based on the reservoir. This reservoir, you have to create the dam, I think reservoir. And there are so many that's the environment, the problems with the reservoir base. So that means you cannot have the reservoir unlimited. There's a limitations to put the reservoir. The submergence is limited, and the environmentalists, they do not allow to use the huge number of the. So that means these are exhaustible. That means you can say that there's a limit of those capacity of those plants. Hello, can he be connected directly or no? No.
No, sir. Only
okay.
In the chat
so
box.
I think it is like that only. That means the non-conventional source or renewable energy source, these are that they don't have the limit. They can be renewed. So in that case, we don't stop the water. We don't create the things. So that means there is a limitations to put up. Those sites can be exhausted, or I can say they are exhausted. So large hydro concept was the reservoir based. So now we don't create the reservoir. Nobody will allow to create the reservoir. The big reservoir. Very few plants which are under construction, but not new power. So that's why I'm talking.
Thank you, sir. There is another participant, Dr. V.V. Bhavsar, sir. He is asking question. Please ask, sir.
How tidal energy converted into electric energy, sir?
That is the different concepts of tidal energy. We have the three, even we have the potential energy, and so also in the tidal energy and kinetic energy also. So there is two different technology will be used. If the tides are very high, so then during the tide and web, during tide, the water will be rise a very high level. In that case, it will be filled in a tank. That way I'm telling you. And during web, that water will be moving from that tank to downside. So in that case, you can use that potential energy. So in that case, we have the the concept is the same. But if the tides are very, you can say very less, or you can say it's not a very high. So that means the potential in tides will not be available in potential energy. It's a kinetic energy. So there is a type of turbine will be different. That is like a windmill. So windmill type turbine will be useful for that. So that way I can tell you, sir. It's entirely different, and that technology has not been developed, at least in India. We are talking about the conventional hydropower station. So that is that. So here the tides may have potential energy as well as the kinetic energy. So different type of system we have to use. So I think I should continue this.
Yes, sir. Please continue.
Yeah. Then otherwise, I have a lot of many slides here. So I think it's again this is a confusing thing, that why we have 25 megawatt and all the countries have different capacity for defining of the SHP, small hydropower. So in India, till now I'm talking about, still, if you are talking about the small hydropower, so plant capacity will be up to 25 megawatt. Beyond this, it will be considered large hydro. And then again, question, what is the difference between large hydro and small hydro? I can say technically there is no difference. There is the same route we have to follow to tap this. But the thing is, it is fixed. It is decided by the government, the MNRE, Government of India, just to give the incentives. That means they have fixed this capacity that up to 25 megawatt, they can give some incentives, not beyond that. That means if you want to, as a private developer, if you want to develop a plant, so and you want to have the subsidy from the government, so the government says that if you go to the MNRE site, the guidelines are there. There is a provision guidelines are there. So that means they say up to 25 megawatt you can get the subsidy. Beyond 25 megawatt you will not get the subsidy. That is the thing. So that is the only basis to have this. Now, I think the question was that in the hilly bays and in the Maharashtra or in the Gujarat, that if we don't have the hills, so where this hydropower plants are can be established or being established or already established. So that is, we can classify the hydropower plant runoff river, canal fall based or dam flow based. These are the sites which are potential sites in India. I'm talking about to develop the hydropower space. So let me tell you that, okay, these slides are there. They are self-explanatory. You can read also, but I have to finish all these things. Otherwise, so I think you can see this figure. So here, these are the hilly based sites. In hills, what we do, that means it's a natural stream. So that natural stream may have the huge quantity of water and it's not, you cannot use the total discharge, total things. Depending upon your plant capacity, you can divert the water, and this is the upstream. This upstream, that means the divert, and then it's a 4-bay tank, and from there you immediately just allow the water or transport the water through penstoke, that is turbine inside there, and this is the thing. So this is the typical layout. I think you can see the real picture of this, actual picture of this. So that means that stream is flowing somewhere here in this route. I think this is again going. I think this stream, I think I have tapped this. I think this 4-bay tank I put here at this location, and the route of the stream may be somewhere here, and that even 10 kilometer, 15 kilometer route. But I think to shorten this route, I take this 4-bay tank here, and directly this head is a penstoke. This is the pressure. It's a pressure minimum water conducting system in order to avoid the losses. And here's the powers. So again, this I tap this head here, and the water goes again in the stream, same stream. So this is the location of the thing. Then next, I think if you don't have the hills, you may be having this canal network. So in this canal, the huge quantity of water will be there, but the head will be very small. And you know the power is Q into H, head and discharge. So if you have the huge quantity of water and less this head, then even then you can tap. So here, this is the existing canal. This is the existing canal. So you just what you do at that same level, you just make a diversion weir, and this diversion weir you put the plant, so that when you can stop water in this, it will go here, the head will be tapped. So that is the canal base. Here, this is the second type. And the third type is there. Let me tell you that in Maharashtra, that most of the plants are the dam based. I think those dams, those reservoirs, they were not built for power generation. They were built to just supply the water for drinking water or for irrigation. I think there are so many existing dams are there. But I think we thought that under small hydropower, that when they release the water to supply to the city for drinking water and for irrigation, so because water quality is not get deteriorated, or it is not consumed in the hydropower station. Only potential energy or the pressure energy is used. So I think, let me just, you see here, that means when they release the water and it goes to the channels or canals, so this head is unutilized. It is just like you are wasting. So what we thought, that if this water, instead of from the top, we just release the water from the bottom like this, and that water should be through the turbine. This turbine will tap this potential energy, this head, and the same quantity of water will go there. So that means this is the plant. This is known as the dam toe. Dam toe. That means that the toe of the dam, and it's a very simple installation. You just put a hole in the dam, put it pipe, and release the water, whatever. Suppose you need 4 hours in a day to release the water from this dam. So don't release the water from here, release the water through this, so that potential energy can be used to generate electricity for 4 hours. Depending upon the duration of the water, you release the water. So these are the dam two. So that means in Maharashtra, in Karnataka, the many hydropower stations are like this, that they are dam two. They don't have, they have limited canals, they have limited hills, but still they have many reservoirs and sufficient head. So that means the many hydropower stations are dam two. It's clear now, I think. And this is again, is a one kind of that, because sometimes it's a the pump storage plant. Nowadays it's very in an emerging area. In that case, that because this is peaking power and it's very sometimes the surplus energy is there. So in that case, you can use that surplus energy. Of course, it will be the this reservoir base only, reservoir plant base. So here, when there is a need of electricity, you release that water to this turbine, it will generate the electricity and it goes to the grid. But few hours, in 24 hours, there is surplus energy in the grid, and which is not used. So in that case, that electricity can be used to the same machine. That this turbine can use a pump, and pump can use a turbine, and generator can use a motor, and motor can use a generator. So during that period, you can pump that water, because whatever water has come to the downstream, it don't have power, because power is due to head. So what they do, that during that period, they just draw the water from the tail race and lift the water again to the reservoir. So of course, it will not be, in normal case, it will not be economically feasible. But when there is electricity surplus, it is going to a waste. So that means during that period, you can pump this water from the lower reservoir to the upper. Then when you need more power, then that will be used there. So I think in other countries, in many countries, they are just utilizing like this. They have the pump storage scheme, but when there's a demand is more, so they sell the electricity at higher price, and when there's low demand, they sell the electricity at a lower price. So this way they manage to do this, because the same water can be lifted on that. So now I think I'll be very quickly in this. So let me tell you that in order to develop the hydropower plant, there are 3 types of components. One are the civil components. That means this water has to be diverted and take to the turbine. That is one thing. And then the same water has to come out from the turbine. It will go to the downstream. So these components come under civil works. I'll tell you the civil work. And inside this powerhouse, we have the turbine and their control system, and the for electricity, this generator. That will be known as the electromechanical equipment. So we have to design, depending upon the site conditions. That means, let me tell you that if you have this type of site, that is a hilly base, so the components will be this, this diversion to divert the water, desilting tank to remove the silt from the water, and the head race channel to transport the water to the forebay tank, and from the forebay tank is supplying the water to the turbine, to penstoke, and the tail race is that it convey the water from the turbine to the, again, that is steam. So these are the things, powerhouse building. So all these things comes under civil work. But when you talk about this canal base, we don't have the forebay tank, we don't have the power channel. It's simply, that means you just install the turbine in the canal or the bypass channel. So that means according to that, what components required. Similarly, in this dam toe base, we need only penstoke and the powerhouse building and this tail race. So these are three components we need only under civil work. So only machines and are there. So, so that's why I'm just classifying the civil works. These comes under civil works, and these are the equipment, this turbine and generator and control. So under civil work, I just give the thumb rule. I think it's again a civil engineering that you have to design, you have to consider all the losses and other things for each type of component. So in this, the civil works, the capacity of the civil works totally depend upon the discharge. So design discharge, you take the basis, and then you have to calculate the size of the I think, are you able to see the title of this slide? No. Hello?
Yes, sir. Yes, sir. It is visible.
It's hidden inside me. What is that?
Intake structure.
Okay, intake structure. So this is the intake structure here. This is the intake structure, that diversion. That means a small dam, you have to just put across the channel so that the required quantity should flow in this power channel. So that is also it is a different type of them. So that means again, civil engineering, there's no time to discuss all this thing, but I'm just giving the flavor of that. So what type of channel, and this anyway, this is a power channel or what is this? Yeah.
Yes, it is types of power channel. It is visible.
Yes, power channel. So the power channel is which transport the water from the intake to the forebay tank. So again, we have the various types. It's a simple civil engineering you have to apply this to design the power channel, to design the desilting tank. Desilting tank. Actually, basically, this is also very important component in civil engineering. That means you know that this natural water, and this water may contain some silt particles and some pebbles also. So that means if you don't remove that silt particle before water goes to the turbine, it may damage the components of the turbine and other components. So it is necessary that we have to remove that. So there is a very simple mechanism here to remove the silt. What we do, that means we just enlarge the area, cross-sectional area in the power channel. So that means in a power channel, velocity will be sufficient, but when you enlarge the area means is width, long, and even depth. Volume you can increase. So that means along that tank, just I'll tell you here, many things I want to describe. This tank. So that means up to this is the cross section of the channel. But when you increase the area, what will the velocity of water will be very calm here in this, because the same quantity over a larger area, velocity will be less. So when the velocity will be very less, so this particle, these silt particles or pebbles get settled down. So there's no any extra mechanism we put here. So that means that silt is removed from the water before it goes to turbine like this. This is not the desilting tank. Then I think this is forebay tank. This is also very important component. I just quickly I'm telling you that this is the forebay tank. So this forebay tank basically used to connect this circular pipe to this rectangular channel. That's one function. The another purpose of this, sometimes when the water is flowing in this direction under pressure and suddenly the machine is stopped, by any conditions you want to stop suddenly. So what will happen? The back pressure will travel in this pipe. Suddenly the pressure will be going back. When it will come over here, so that means this, if you don't have any cushion, so this water will be splashed out of this tank. So that may damage the neighboring things over there. So that in that case, the design of this tank is such that the quantity of water should be that much. That means it will act as a cushion. That due to the weight of the water in that back pressure will be killed. That means there should not be any splashing. So that this is the basis of to design the volume. As a thumb rule, with the volume of this tank, we consider 2 to 3 minutes capacity of this tank should be there. That means if I have this one cubic discharge, so that means 1 cubic discharge means I have to provide the volume of this. So that means 120 cubic meter size of the tank will be there. So that means 2 minutes storage. 1 cubic means 1000 liter per second discharge. And if I multiply 2 minutes this, so that means its volume will be 1000 into 120 seconds. So that will be the capacity, this volume of the, I think this, again, I'll miss the many things if I keep on discussing. So the next component, the very important component is the turbine. So here, quickly I'm talking about, that means when we discuss the power is the Q into H, the discharge and head. So there are two parameters. If you have the high head, very high head and low discharge, capacity can be sufficient. They can be, I can tell you, suppose I have a 10 meter head and 10 meter, 10 into 10, that Q is 10 and head is 10. So what is the multiplication? 100. If I have 100 head and 1 head, so again it's 100 kilowatt. And if I have 100 meter head and 1 discharge, it will be 100. So that capacity can be obtained by the multiplication of head and discharge. So, but the turbine will be different, because when you have the high head, suppose 100 meter head, so only one unit of discharge is required. So size of the machine will be very small. And if you have the huge quantity of water under low head, so turbine will be bigger. So that means one type of turbine cannot cover the entire range of the hydropower. So we have used this hilly based, that is very high head, canal based, which is very medium head, low head, and dam toe, these are medium head. So I think that is the basis. We have 3 different types of turbine: Pelton turbine, Francis turbine, and Kaplan turbine. So these are the turbines. That means for this Pelton turbine is used for high head, and this Francis turbine is used for medium head and medium discharge, and this Kaplan turbine is used for low head and high discharge, because their characteristics again needs many hours to discuss their working principle, but I have to cover the entire things. So in this case, let me, so now that I just give the one simple exercise that how you will decide different type of turbine. So in this case, just consider this only Pelton, Francis, and Kaplan. These 2 types, this turbo impulse and the cross flow turbine, there we call this a non-conventional turbine, which is suitable for a lower capacity. That will say a few kilowatts or 100 kilowatts, not in megawatts. But the Pelton, Francis, and Kaplans are recommended for largest. These are the conventional turbines. So in that case, if you have any site and you want to select the which turbine will be suitable, so the basis is only specific speed. Please remember this is specific speed. There's no time to discuss what is that, but you can remember this formula. This specific speed formula is this is the RPM of the turbine, and this power, this capacity of the plant, and this head is the H is the head. So in that case, if somebody comes to you and asks that, please select a hydro turbines for your side, his side, so then you can ask what is the capacity of the machine or the plant. He will tell you that that is the capacity is in kilowatt, and then you can ask that what is the head. So you will ask that this head, he will tell that the head is particular head, and then the speed you have to assume. And this assumption of speed is tricky. That means if you want to couple the generator to the turbine directly, so the speed of the turbine will be the speed of the generator, or generator speed will be the turbine. So that means just assuming this speed, and taking the plant capacity and take, if this figure comes, you just whatever value will come, it will not be written as a RPM order. Of course, the dimension, but it's a number. I can say this is a specific, this is the number. So that if that specific number comes between 342,000, that means between this, say 360. So immediately you can say the Kaplan turbine will be suitable. There's a low head turbine will be suitable. If it is between 80 to 400, then you can say that's a Francis turbine. And if it's a for 20 to 70, say the turbo impulse. So this is the things, and nobody will challenge you that if you determine this number based on the power, based on the head, and assuming the physical RPM, then you have to tell. That's a very simple exercise I'm telling you. Then sometimes there is a overlapping. That means here is a 350, so that, or 360 will be here also and here also. Then you have to find out that which turbine will be most economically, then you go for that turbine. But technically both the turbines are correct. Means technically both turbines are right. That means, but the cost will come into picture. Then you have to contact to the manufacturers. You can say either Francis turbine will be economically, or the Propel or Kaplan, then you can. So these are the characteristics. Sometimes I tell you that these are the operating characteristics. In a hydropower station, machines will behave like this. What is the behavior? That means their maximum efficiency will be there at the full capacity. If you can operate the turbine at a lower capacity also by adjusting the head or available discharge or discharge mostly, but the efficiency will be like this. I think you can see here. That means if I want to operate a turbine at 40% load, it's a load basically. This is, suppose I have a 100 kilowatt plant. So if I want to operate the 100 kilowatt, it will be operating at the maximum efficiency. But if the turbine is operating as a part load, so its efficiency will be, and their behavior will be different. I think you can see that this first one, Kaplan turbine, can operate a wider range of the variation. That means from 20% to 100%, if you vary the load, its efficiency will be almost same. And the two is the Pelton turbine. Of course, its efficiency will be covering a wider range, but its efficiency is is inferior in comparison to Kaplan. And the Francis turbine is considered I think it is not suitable for part load efficiency. It is suitable for the near to the rated capacity only. So its rated capacity will remain the peak efficiency. Otherwise, its efficiency will be lost. I think these are the things are. So then hydro generator, quickly I'm talking about, and basically there are two types of generator, induction generator and synchronous generator. In most of the almost all the hydropower generators, they are synchronous generators. And induction generators, of course, they are less costly, but they have the many problems. So because of that, we don't use the induction generator, we use the synchronous generator. Again, it's a electrical background student, the participant, they can understand this. But here I tell you that in most of the cases, or almost all the cases, the synchronous generators are used in hydro, or the hydro generators are synchronous. this is the, I think some problems are there because their obsession, the silt is the, in India or in Himalayan region or in Nepal, the severe problem in hydro is the silt erosion. So I think just 10 minutes are just, this is all technical thing. You can read that these are the self-explanatory. So I have because I want to interact with you with the questions, but quickly I'm doing it. So that means, let me tell you in a very quickly, I have few slides with you in this. You can read that they are self-explanatory, but I tell you the few points related to this environmental impact of small hydropower. So before I just say, I tell you that means the environmental impacts on of this large hydro is very, very severely that, but in for small hydropower, very, very, very less. It's not there, but still we have to discuss that. So SSP plants are not supposed to create, I'm just read quickly, have this serious environmental impacts, have very low running or maintenance costs, have long project life, is there. That's why these are very, 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 I think, I can say advantages to install a small hydropower plant, because the environmental problems are very, very less in comparison to the large hydro. So what are those? I think I prepared the slides in detail, giving some details. So I think those will help you when you read yourself, but because the time limitations, I cannot discuss much about this. So I think the impact affects different aspects of environment, affects the flow regimes, migration of organisms, and basically the most critical impact of SSP is on the aquatic species. I tell you that when you divert the water from the main stream to the power channel, so the problem comes over there, because the water level sometimes, because even of course the government, there's a guidelines that you cannot dry the main stream by diverting the water completely to you for your power generation. They have to release at least 10 to 20% water just because of this problem, environmental problems that affect the fish and other organisms living in rivers. I think it's again the points I'm just highlighting here, but it's just again this you can say this discipline because who are dealing with in the environmental aspects, they will be comfort to understand all these things. But these are the points I listed over here quickly, so you can read these. I tell you that there's not much environmental problem. It's only micro level or mini level. If you are very much even in for research purpose, you want to investigate some impacts, you can do research. But as far as the this practically concerned, it's not of that high intensity. So environmental SSP is a first order upstream and downstream. So these are the points I have listed over here. You can read that, and depending upon your requirement, you can discuss. And even after that also, you can discuss if any problem. So there's a typical, for a typical plant, these are the order of this, what is the solid material suspension, water course, fish migrations, fish mortality. I think in India, we don't much critical about this also, but in other countries, they are very much, this developed country, they are very much, they have the concern about the fish. And they even nowadays, the fish-friendly turbines are developed. That means if fish pass through the turbine, it will not be harmed. That will be okay throughout the turbine also. It come out from the turbine. So these are the points. I think just within 2-3 minutes I'm just. So then the positive and negative impact is listed over here. So that's why I'm quickly, that is, if you read this, it is self-explanatory, you will understand easily. So, because I want to spare time for your discussion. So this is also there, that is the um, I think sometimes somebody wants to work in the area of this impact of the this small hydropower on the environment. So that means this is the basis you can work. And I can tell you that this particular table just give the guidelines. Otherwise, it will be different for different type of. It depends upon the where is the location of the hydropower plant, what are the measures are adopted during the construction of that. So it depends upon that. So that means this exercise has to be carried out, should be carried out at least for all type of or all hydropower stations through EEI. And I tell you that it's not, of course, that so many questions comes in this regarding to develop the small hydropower I'm talking about. So, but there's not much impact on environment. Basically, there are three issues are there. One is that water release. That means in the stream, you have to, because sometimes at some site, the developer wants to draw the complete water in order to produce the electricity. They don't follow the guidelines. If they follow the guidelines, there won't be any problem, because at least 20, in some states, you have to spare the 20% discharge, leave the discharge in the natural stream or the original stream, and sometimes 20%, 10% like this. This is the guidelines so there. So if they follow, then I think that will not be the problem. Sometimes the this muck disposal. That means that is the problem. They don't plan to dispose the muck. That means that immediately they just they excavate the things and they put in the flowing stream. That is harmful. But guidelines are there, so that means if these guidelines are followed, then there won't be any problem. But these are the things I think you can study. Then I don't know. I just put so many things, but. And there are some things that means if somebody really wants to work in the hydropower area, this R&D I'm talking, research, where the scope. So the scope is there. That means if somebody, there's a mechanical background person or teacher or faculty, they want to work in the design of the hydro turbine. So I think I tell you, hardly any scope to enhance the efficiency of the turbine, because nowadays the manufacturer they claim 95%, 96%, 94%. So hardly any scope in that. But under different conditions, different site conditions, there is scope. That means turbines in most of the cases they are not operated on the rated capacity. Under part load efficiency, they have to be operated, so that there's a scope to enhance the efficiency of their life under the part load efficiency. Part load efficiency, what does that mean? Suppose I have a plant capacity is 100 kilowatt and the plant, the turbine is of 100 kilowatt only, but how many months? It may run, it's say 6 months, 400 kilowatt, but most remaining 6 months, it can be 50 kilowatt, 75 kilowatt. So that means the turbine efficiency will be very low under the part load. So I think there's a scope that how we can enhance this part load. And another thing is nowadays, because we are lagging in this is digitized. That means the data we just collect, or the operation we just get the signal manually. So that means there's a scope of that. That means if the things can be digitization like other plants, so it will at least improve the efficiency or the production of the, because that is the thing. So another thing is the storage. So that can be, that's why I told you in the beginning, the pump hydropower storage schemes are very popular nowadays. So new hydropower stations, they are planned with this pumped hydropower storage based. So this is the things. Generators, very novel power electronic cell with not much scope in that. Not particularly, I'm talking about the hydropower generators. They are similar to other generators. And the questions was asked by some participants that nowadays I can say that most of the sites are identified, which is conventional site, the head base. But still there are so many problems to install. I think the first problem is that nowadays the government of India giving the lowest priority to develop the hydropower plant. And before, I think 10 years back, this hydropower development was the number one, and along with the wind. Now there's, you know, that solar energy or solar plants are number one, but hydropower is not the priority now. But as a researcher, I'm talking about there's a lot of scope here. Just the things some participant asked that how we get tidal energy through this route. So there's a scope of hydrokinetic turbine. I think you can read that, the hydrokinetic turbine. These turbines are suitable just to tap the potential which is available in flowing stream, because the conventional hydro turbine needs head. If you have the water coming at a higher level, then only they will be operated. But there are so many sites. I think if you talk about the canal based, I just discussed the canal based conventional hydro turbine. That was basically if the head is available, and that head will be maybe 5 meter, 10 meter, 8 meter, then only the conventional turbines are feasible. But if in the flowing canal, there's hardly any practical, means practically there's no head. I can say zero head. Of course, zero head will not be there, but we can say the zero head. Zero head means the water has the current only. Current means the flowing, the velocity. So that means there are a lot of potential. There's a lot of sites in India where this type of potential is available in the flowing stream. So in the flowing stream, the turbine will be different. And I just give the basis, just to think that it's not different. All kind of wind turbines can be used as hydrokinetic turbine. All kind of, like a propeller turbine or any type of turbine, Savonius, Darius, whatever turbines you might have studied in wind, they can be used as hydrokinetic turbine on the same basis. And I tell you, though, what is the beauty here? That means to get this substantial amount of, or the feasible amount of energy in wind, you need a very high velocity, say 10 meter per second, 5 meter per second, or 15 meter per second, like this. Why? Because the density is very low, 1.2 kg per meter cube. But hydro is almost 1,000 times density is there. You know, the 1,000 kg per meter cube, and there 1.2 kg meter per cube. So that means even a very low velocity, because if I am talking about the potential energy, it's okay, mgh, but here is a kinetic energy, purely velocity energy, half mv squared, half rho av squared, half rho av cube. So that means the velocity you can measure, and the rho here in case of water is almost 1,000 times more than the air. So that means you can say that substantial amount of energy or power you can develop through this technology. So a lot of work, if you search, you go to Google, you find that many countries are working in this. But the thing is, what is the scope I'm telling you? Still the site conditions based this design is not tested. That means we also working, particular myself is also working in that, but we are working in the laboratory, we are just doing the R&D in that, but now we have started because we have to bring this into the field. So I think this is why I'm giving the more emphasis. That means any discipline faculty can start, they can start working in this hydrokinetic. Just like hydrokinetic turbine, then a lot of things you can get from the net. And the fish-friendly hydropower technologies also I have told you. So this is the things. So I wanted to discuss many things or technical things, but because of the time constraints, 2 hours is very less for me. So I try to cover everything, just basic things, so that you can ask the questions. I'm here. Madam, you can please.
Okay,
Sorry,
thank you, sir. Thank you, sir, for your presentation. Sir, you can stop sharing your screen
okay.
so that we can.
Yeah, I should. Yeah, yes.
Okay, thank you, sir. Session is open for the discussion. Now I request participants who are present at the hall as well as present at the online platform to raise the question. You can unmute yourself and ask the question. You can raise hand or you can put your question in the chat box. I will read on behalf of you. So first I request a participant from the hall to ask the question.
Please feel free. That don't consider that
Yes.
I'm an expert. I'm just feel free, and any basic question you can ask, no problem. I'll be okay.
Yes, ma'am, please.
Sir, as this hydropower plant has critical impact on aquatic species. Hello.
Yeah,
ma'am, please speak loudly.
Loudly.
Sir, as this hydropower plant has critical impact on aquatic species and some fish-friendly hydropower technologies have been shown, is there any additional cost for these technologies?
Let me put my this. I'm not able to.
Yeah, can you,
madam?
Yeah, can you repeat his question, madam?
If fish-friendly hydropower technologies are used in hydropower plant, will it increase the cost of the plant?
No. Actually, it's a design. That means because basically turbine consists of a rotating body inside the turbine. So that means the design of the turbine, the angle of the turbine will be such that means the fish will not get any harm in that. It may pass through without losing the efficiency of the turbine or just compromising the efficiency of the turbine. So that means as far as the plant cost will not be. Only thing, so the turbine which is under research even, that it should be redesigned that way. It should be optimum. So that means the cost is in the research only, but once the turbine will be developed, it will be the same cost of that.
Thank you, sir.
I think it's clear.
Yes, I want to ask one question. Ma'am, please allow me.
Yes, sir, please.
Yes, sir. Good afternoon, sir, and thank you very much for very enlightening lecture on small hydro projects and its potential. Here, I am Harshvardhan from College of Forestry, Dr. Panjabrao Deshmukh Krishi Vidyapeeth, Akola. Here, I would like to ask you, sir, regarding what are the indicators you have talked about the small projects indicators, that is reliability, then cost effectiveness and efficiency. So how to measure that and what are the indicators for that small hydro projects?
Yeah. Yes. So as far as the reliability concerned, that means if you have very much cautious about the potential estimation, because most of the hydro power plants fail because of the reliable data. I think you got it. That means without investigating properly that how much potential, what is the trend of the discharge available at that site, and without realizing that, without estimating proper estimation, that you just estimate and they put the machine of a particular size. I just give the example that sometimes you say that the design discharge is of a particular value, and based on then you select the equipment, and finally when you install the turbine over there, you don't find that discharge. It may maybe under size, under discharge or that thing. So that means reliability gone. The failure of that is the one thing. And is the there this the cost is again this is depend upon the, if you have the standard size of the sites. So that means the machines can be produced or they will be available. Let me tell you that the earlier, that means 10 years or 5 years, all the developers in India, private developers, they were interested to buy the Chinese machine. So I don't say I never objected that that they are not of good quality or they are not efficient. They were efficient. The how they have brought the machines cost down, that because they have produced the machines in mass, and then while selection of the turbine, they just, जिसको कहते हैं ना, किसी भी उसमें भिड़ा दिया उसने तो अगर वो सही सिलेक्शन हो गया तो वो परफेक्ट हो गया, और नहीं तो वो रिलायबल नहीं रहेगा. So these are the things. Efficiency is almost there because it's a properly designed. So that way I can say, but all the three things, the indicator is like that only. That means you have to be very cautious about the potential estimation. That's why I'm talking about this flow duration curve is very important, and it should be based on the reliable data. That is the basic problem. We don't have the reliable data in our data bank.
Okay. Thank you very much, sir. One more question. Please allow me to ask one more question.
Please.
Yeah. Sir, as you see, the means this hydro projects, it is comes under the developmental projects, whether it is small hydro projects or large hydro projects. But when we are at to implementation phase, we have to means cross with a lot of socio-economic issues. So how to deal with that issues when you come to means when you want to design or implement these small hydro projects, because it's totally governed with the stakeholders. So how to deal with the stakeholders, major stakeholders, that is users.
Yes, I think it's a under planning only. That means if you have a competent person to plan your project, so that means the problem start from there only, because it will depend upon, you know, that any projects will depend upon the DPR, the detailed project report. That means sometimes you just I think you save your money. Let me tell you, that means a person who say that I will prepare your DPR in 2 lakhs rupees, and another says 20 lakhs rupees. So what you will say, that DPR is the small documents. It's a document. It's nothing but. So that means if you want to say, that means you have saved that 8 lakhs, that's 18 lakhs rupees in DPR, and you have just started your project under planning, that's a 2 lakhs rupees. So I think that's the problem. That is the starting point, because everything will be vague. So that means that is the things. And then finally, after that, some problem will be there. That means the local problems are there. That means the locals, they start creating the problem during constructions. They ask, they demand, they exploit, they may exploit that. So all those, these are the main issues in development of hydropower plant, small hydropower plant I'm talking about. So the local issues are there and the technical issues are there. That means if you don't have the competent, you have not hired, you have not appointed the competent this technical person, then these are the two things. Otherwise, once if the turbine, this your machines or your plant is based on the accurate hydrology or data or everything, so that means ये इसको कहते हैं कि सोना बहाएगा फिर ये फिर बहुत जल्दी उसमें उसका होता है. अगर आपने कहीं गड़बड़ कर दिया तो तब प्रॉब्लम है, फिर तो पूरा डूब जाता है आदमी से, पूरा डूब जाता है.
Thank you very much.
Thank you, sir. Now I request Dr. Rupna to raise his question.
Good afternoon, sir. Nice presentation. Thank you for your presentation. I have two questions, sir. My first question is, as you told about the canal-based power plants, that is installing the turbining on canal system. So, is there any effect on the flow rate of the water, that this water is ultimately going to the farmers' land?
Not at all. Not at all. Even this, why I'm talking about the diversion weir, because when you need to install the turbine in the canal, so that means during construction, you have to stop the water. So that is, sometimes the canals are lifeline of that area. So if you don't want, because nobody will, these canals are governed by some other departments, and power departments deals with the power generation. So they will not allow to stop the canal. So in that case, near to that, across, I think you can see that there's a bypass, this thing, this diversion weir. So that means you construct the diversion weir at the same level that, and put the turbine in that, and then after release the water. So the complete water will go to that in the turbine. So there's nothing happen in that, the same, because the hydropower station, the hydropower plant, they don't consume the water. They just extract the potential energy.
Okay. And second question is, as we discussed about the reservoir-based or large hydropower plants. So
Yeah.
these hydropower plants, can it be possible to convert them into a hybrid system where photovoltaics, that is the floating
Yes.
PV panels, can
The,
be installed, or can be
100%. Nowadays, there is an emerging area. That means there's a research and a lot of work has already been started. Even wind. If the wind potential is there, so then you can have the wind plant along with the hydropower station. And it's just like that. As I told you, the pump storage. So that water which has come to the downstream, which is don't have any power. So if you can lift that water again to that in the upstream, so again it will develop the power. So that means if you want to integrate the other resources which is available along with that, so it's a hybrid system. So hybrid system now, this pump storage scheme, just like means on the similar line, you can integrate that the wind energy, you can integrate the SPV. So now plants are being developed. There in India, they have started working.
Is there any
Very
existing plant which is having photovoltaics or wind turbine?
Basically, presently I don't remember the name, but still they have started. There are some plants are there under scheme, and even the government of India, they have approved this, and it is very much you can say the emerging area that people they have started working.
Thank you, sir. Now I request the participant from the hall to raise question.
Sir, good morning, sir. Myself,
Good morning.
Chaudhary from Forestry College, Dr. Panjabrao Deshmukh Vishwavidyapit, Akola.
Yeah.
So, the Dr. Deshmukh says that there are social conflicts which are usually appears when the erections of the hydroelectric power projects. My concern is that there are also some environmental concerns for erections of hydroelectric power plants, either it is a small or large size. There are huge amount of forest is being destroyed, I would say. So how do you see this problem? How to mitigate those losses? Of course, I am not against of the generation of hydroelectric power, which is a necessity for the country. But how to mitigate these losses? What is your
I can say that I think I have put this point, elaborated this point in the PPT also. You can read that from there also. But I can tell you this, in a small hydro, if you talk about the canal base, so in canal base, the turbine will be put in the canals only. So there is no problem in that. But in the hilly base, base site I'm talking about. So that means that during plan, That means when you draw the layout of the hydropower plant, so that time they take the care, because ultimately in small hilly based site, the laying the penstock is you need this land in that. So in that case, they try to save the tree, because the penstock size is not a huge size, but they just change the route in order to save the trees. But sometimes if there is a lot of problem, that means you have to remove that. So they say that we have the replant the things. So that way you have to manage that. But as far as the developing the small hydropower, so that problem doesn't come much. I think very you can alter the layout of penstock in order to save that.
What is the corporate social responsibility of hydroelectric power project?
What is the
what is corporate social responsibility which carries the hydroelectric power plants in this regard?
That's why I think I just put that point. That means it is sometimes this is the big problem, and that will depend upon the this area to area. That means sometimes the society or the local people, they start exploiting you, but even they think so. That is the problem. That's why I'm talking about. It's a big problem. But during construction or under planning, the private developers, they manage that. I don't know how they manage. तो किसी को नेता को पकड़ेंगे, किसी को उसको पकड़ेंगे, तो सोसाइटी प्रॉब्लम जो है, आप मैं मतलब बड़े क्रूड वे में बोल रहा हूँ, क्योंकि वो उसको जैसे वो गांव वाले एक्सप्लॉइट करना चाहते हैं, ऐसे नेता लोग उनको एक्सप्लॉइट करके वो सब मैनेज कर लेते हैं. डेवलपर्स, दे नो दैट. बट some because we are dealing so many hydropower plant at site also, but kuch plants jo hai, they really facing this problem. The developers, they are facing that problem. So that is there. They try to tackle the adopting the local techniques only. There's no standard technique for that. That way I can answer that, because when society come into picture, so you know that. Yeah.
Thank you, sir. There is one question in the chat box by Dr. Vaibhav Ujjankar. He is asking, is any regulatory system to decide size of the reservoir of hydropower project to avoid the adverse effect on agriculture and deforestation?
Yes, actually, there's a regulatory means these small hydropower, they should not have the reservoir. I think I don't say that's a reservoir. It's a pondage only. And that pondage will be within the river basin or the stream basin only. So that means this concept of developing of the small hydro I'm talking about, they don't have any concept of reservoir. So that reservoir is just, and that reservoir is not to storing the water, is just to take up the fluctuation of the water. That way. So machine can be smoothly. So that is, we call this a pondage, a small reservoir vacancy.
Thank you, sir. There is another question. What will be the load factor for SHP?
Load factor is depends upon this. We can say the 85%, 84%, 85%, 80 to 90% load factor we consider load factor.
Okay. Thank you, sir. Is there any question from the hall? Okay, thank you everyone. If you have any more question, you can send the question to us. We will email to sir and we'll get back to you. Or you can directly contact to sir also on his email ID. So now I request the participant, one of the participant, to propose vote of thanks on behalf of the participants, online and offline mode.
Okay, I would like to take this opportunity. Thank you very much, madam. So, on behalf of participant, online and offline mode, I sincerely thank you, sir, for your knowledge-rich presentation on small hydro projects. I remember first I came to know about this small hydropower project, not me, I think we all know about this project through the movie called Swadesh, which is directed by Ashish Gowarikar with the lead role by Shah Rukh Khan. So in that movie, we understood, but a lot of things we can't understood. But with your lecture, we understood that movie fully. And with your vast experience, now I can understand the concept fully by your explanation in very simple language, from basics to the recent trends in terms of technology, principles behind it, and you have also make us understand the policies and recent issues regarding the establishment of small hydro projects. You have opened new window to think on this aspect. And on behalf of participant, we assure you to join hands for this green energy. So once again, thank you very much, sir, and we honor to hear you, sir. Thank you very much.
Thank you, sir. Thank you, sir, for your wonderful presentation. A very informative and very interactive session, sir. You have covered the topic very beautifully, from very basic to the advance of the technology has been covered. Our participants are very happy meeting you and listening to you. They are sending the appreciation messages in our chat box also. So once again, on behalf of the NHEP, Dr. PDKV Akola, I am very much thankful to you, sir, that you join us on this virtual platform. Thank you, sir.
Thank you, madam, and thank you, Dr. Deshmukh. And I think so many things you have told me in for the appreciation of that. But if you ask me, so I'm not happy actually, because the area, if even I find that I could not deliver the things which I wanted because the time limitations. So that's why even 2 hours, 3 hours, 4 hours, I want to discuss, but still, I think this book say that it's a opening window that we can take that. And thank you very much. And I could see that many participants, they ask the questions. So I'm happy that, because that questions give the energy to the presenters. So thank you very much. And